Stars are formed in clouds of gas and dust, known as nebulae. Nuclear reactions at the centre or core of stars provides enough energy to make them shine brightly for many years. The exact lifetime of a star very much depends on its size. Very large, massive stars burn their fuel much faster than smaller stars and may only last a few thousand years. Smaller stars, however, will last for several billion years because they burn their fuel much more slowly. Eventually, however, the hydrogen fuel that powers the nuclear reaction within the stars will begin to run out, and they will enter the final phases of their lifetime. Over time, they will expand, cool, and change colour to become red giant stars. The path they follow beyond that depends on the mass of the star. Small stars, like the Sun, will undergo a relatively peaceful and beautiful death that sees them pass through a planetary nebula phase to become a white dwarf. Massive stars, on the other hand, will experience the most energetic and violent end, which will see their remains scattered about the cosmos in an enormous explosion called a supernova. Once the dust clears, the only thing remaining will be a rapidly spinning neutron star, or possibly even a black hole. Planetary nebula is an expanding glowing shell of hot gas that is cast off towards the end of a low-mass star's life. Despite the name, they have nothing to do with the planets, and were so named because the early astronomers thought they looked a bit like planets through a small telescope. Low-mass stars turn into planetary nebula towards the end of their red giant phase. At that point, the stars become highly unstable and starts to pulsate. The outer layers are rejected by the resulting stellar winds. Planetary nebula are relatively short-lived and last just a few tens of thousands of years. As the outer layers drift away from the star, the remaining core shines brightly and is very hot. The core is now a white dwarf star. The ultraviolet radiation pumped out by the white dwarf causes the ejected outer layers to glow, the planetary nebula. Over time, the enriched material from the planetary nebula is scattered into space and will be used for future generations of stars. When hydrogen fuel at the centre of a star is exhausted, a shell of nuclear reactions will start to move outwards into its atmosphere. As a result, the outside of the star starts to expand and cool, turning much redder. Over time, the star will change into a red giant and grow more to 400 times its original size. As they expand, red giants engulf some of their close orbiting planets. In the Sun's case, this will mean the fiery end to inner planets of our solar system, including the Earth. But don't worry, this won't happen for another 5 billion years. While the atmosphere of a star grows, its core shrinks due to gravity. Temperatures and pressures in the middle increase until the conditions are right for nuclear fusion to start again, but this time using helium as a fuel rather than hydrogen. With the star being powered by helium, its outer layers return to normal for a while, and it starts to shrink, get hotter and turn a little bit more blue. However, this stage only lasts for 1 million years or so, as the helium quickly runs out. When it does, the star starts to grow, cool and turn red again, as it enters the second red giant phase. What happens next depends on the mass of the star. Sun-like stars move into a planetary nebula phase, while stars greater than about 8 times the mass of the Sun are likely to end up as a supernova. A supernova is a spectacular explosion of a high-mass star that has come to the end of its life. For a brief time, a supernova can shine as brightly as an entire galaxy, but will fade again over a matter of days. The explosion occurs when a high-mass star finally runs out of nuclear fuel. Without any outward pressure to balance an inward force of gravity, the outer layer of the star collapses onto the core and are then dramatically expelled in a nuclear explosion at the velocity of up to 30,000 kilometers per second. The resulting shock wave creates an expanding shell of gas and dust called a supernova remnant. What remains of a star core becomes a neutron star or even a black hole. After many millions of years, the material in a supernova remnant will be scattered into nearby gas clouds and may eventually be used in the birth of a new star. The majority of elements in the universe were created by nuclear reactions at the centre of stars. It is safe to say that we are all made of stardust of long dead stars. Black holes are very strange objects. They are formed when very massive stars come to the end of their lifetime in a supernova event. Everything that remains of the star is crushed down into an incredibly small, dense object. Close to the object, gravity is so strong that nothing can get away, not even light. This means that we cannot see anything within that region, hence the name black hole. That said, it is impossible to see the effects of a black hole on the stars and materials around it. Gas and dust and other stars close to a black hole can be sucked in by gravity, a bit like water going down a plug hole. As materials swirl around a black hole, it crashes into each other, producing heat and light. Because this happens away from the black hole, the light can escape so we can observe the activity. Once established, black holes can grow by consuming material, stars, and even other black holes around them. Over time, supermassive black holes can develop, and it is thought that these lurk at the centre of other galaxies.